Hey, hello everyone. So, we're going to, sorry, what I should say is I hope you had a good festive period. Welcome back to e-learning, right? We're going to carry on from where we left off in terms of introducing electronics. Now, when we started this introducing electronics, I had said I was going to avoid the maths content, and I'm still going to avoid the maths content. We're going to stick with the theory side. I will make sure that the board notes are already available on the engineering science page that you should have a link to through Glow. If not, let me know on the chat and I'll post a link to that engineering site so that you can get all the board notes that we've covered so far. And I'm going to continue doing board notes on this stuff here. So, what we had covered so far was we had covered voltage and current and resistance and the definitions of them, and we had covered series and parallel, the difference between those two. Oh, that's the end of period one. And we had covered input sensors, so thermistor, light dependent resistor, potentiometer. We had covered how you make hot sensors and cold sensors and light sensors and dark sensors. Those are all input things. So if you remember, on the system stuff, the universal system diagram, input, process, output. I'm using a wee graphics tablet to do all this writing and drawing, so it's not perfect. I suppose my board writing was always pretty bad anyway. Right, okay, so that's the universal system diagram, right? So what you've got is, we've covered this kind of input sensor side. We're now going to look at process. So let's think about a simple system. Let's think about a night light, alright? In a night light, we should have something that detects a low light level. So it detects a low light level and switches on a light in response to that. Ooh. Sometimes if I'm too fast, switches on a light in response to, and vice versa. Vice versa means, and the opposite way around. So if it detects high light, it switches off the light. Okay, what's the simplest way to do this? So the simplest way to do this would be to have a power supply. Remember, that's a symbol for a battery. We've got a light. Ooh, that's a good circle. And then you could just have a switch. Yeah. And that would mean that as a single pole, single throw switch. Should have did all that as well in the switch test stuff. As an on-off switch. So then in this case, it's the person, it's your eyes and brain that detect the low light, and you flick the switch and the light comes on. And then when it gets light outside and there's light in the room, you switch the switch off and the bulb goes off. So that's called a manual system. Okay, manual. That's where a person is doing the detection. Okay. We get no need for the sensor circuit that we know how to design, and no need for any other technology other than, and that's basically just a switch in a room. Okay, so how do we do this automatically then? The opposite of manual is automatic. If we want to do this automatically, that means we have to replace that switch, right? We have to replace this switch with a device that will respond to an electronic signal instead, because we know that we're going to have a power supply. Oh, a power supply. And we're going to have, it detects low light, so we want a darkness sensor. So you should hopefully know what way around that goes. That would be the LDR on the bottom half. Okay. And fixed resistor on the top. And then we're still going to have our light bulb as our output device. Oh, goodness sake. Okay, it's slightly better, but it's still not great. And then what we're going to do is we're going to replace this guy. Now I'm going to zoom in on this just so I can get a bit more of an accurate drawing here, right? So we're going to replace the switch with a device that's like this. It's a 3-terminal device, alright? It's called a transistor. It's got a wee arrow on it like that. Lovely jubbly. We use this device as a switch, right? If I just connect that to that, There we go. See how bad that drawing is when I zoom in now. Let's get back out there. Okay, so I've replaced the switch with a transistor. So what happens now is this voltage here will go up when it gets dark, and this transistor will detect that this signal has went high and will close that connection in there. You can just imagine it being like a switch inside there, so that when this signal goes high, the switch shuts and the light bulb comes on. Okay, so this is an automatic circuit and it uses a device called a transistor. So we're just going to have a little chat about this device, this transistor. I'm going to see if I can use Yinka. I don't know if Yinka works on my computer at home, but we're about to find out. You can use it only if you're at home. I'm at home then. Right? When you start using Yinka, you'll send an email request. You cannot continue dealing with this has been verified. Right, well, I'm not going to do that on camera. Right, okay, so let's just stick with this then. So let's talk about this transistor. Okay, so the transistor. The transistor is a device that has 3 connections. You need to know the names of the connections. You need to be able to recreate the symbol, and you need to be able to explain its operation using correct terminology. So the 3 connections: the base, the collector and the emitter. Okay, so on the transistor, we draw that symbol. I want you to get used to seeing the symbol drawn because I want you to draw it. Right, the arrow pointing out the way. This one's the base, this one's the collector, and this one's the emitter. Okay. When you explain the operation of this transistor, you should be saying things like when base voltage goes high, right? So when base voltage goes above, and then there's a really important number, 0.7 volts, right? The transistor is said to be saturated. All that means is that it's fully on. Saturated. Sometimes 0.7 volts is called the saturation voltage, and what I should say is you should be really careful here. When the base voltage goes above 0.7 volts above the emitter voltage, so it's actually this voltage that we care about, right? It's the voltage difference between base and emitter, right? So when the VBE, normally I write it lowercase, yeah. So when VBE goes above 0.7 volts, the transistor is said to be saturated, and what that means is the collector is connected to the emitter with a, it's as if a switch has been closed, right? So you can, what I used to do is, I used to do a kind of a daft thing, I would say. Yeah, I don't know if I'll be able to do it here. Right, so there's the base. There's the collector. You can almost just think of it as like a switch between the collector and emitter. Inside here, I would draw various magical symbols. There's a wee magic wand and a witch's hat. And I would say in here, that's where the magic happens, right? Transistors are really complex devices. You can do a hell of a lot more with them rather than just getting them to act as a switch, okay? But at National 5, National 4 and 5, all we do is use them as a switch. So what we've got is, when the base is raised to a voltage of 0.7 volts above the emitter, the collector and emitter are closed. So we can have this circuit here, which is a little darkness sensor that detects or sorry, that sends a signal that's proportional to the light level. So as light level goes down, this voltage goes up. If that voltage goes above 0.7 volts, the transistor will saturate and the light bulb will come on. So the light bulb comes on when it's dark. So that's us got a full system: input, process, output. We've got an input, which is the dark sensor. We've got a process, which is detecting the switching action and saturating when the signal is appropriate. And then we've got an output device coming on. What I'm going to ask you to do is, I'm going to ask you to access the notes in an assignment. Okay, I'll explain it in this video and then I'll set the assignment separately, where I want you to draw circuits that essentially look like this. The only things that are going to change are going to be the sensor and the output device. Okay, so I just want you to get used to drawing circuits and understanding circuits that sense different things and that generate different outputs. And all of the circuits I'm going to ask you to do are going to be automatic circuits, so that means they're all going to have a transistor in them. Okay, so pretty much all the circuits I'm going to ask you to develop are going to be the same as this. So let's write out some questions here then. Okay, so question 1, I'm going to ask you to draw in fact I might type this because it'll be faster. Faster and neater. Okay, so question 1. Draw a circuit. It's not a system, it's a circuit we're doing. Draw a circuit that creates airflow when temperature is high. Alright. Question 2. Draw a circuit that creates linear motion. No. When light level is high. Question 3. So the hardest one. Draw a circuit that creates. Draw a circuit that creates sound when a rotary control is turned. Yeah, we'll just call it that. We'll just do those 3 questions. Okay. So just to clarify, this circuit creates light when light level is low. You've then got another 3 to do. Okay. I would also suggest that you, I think maybe, okay, right, question, well, it's not really a question. Copy out the previous slide. I'll copy it and memorise. Copy it and memorise the previous slide. Okay. Let's take it away. Describe the operation of the 3 circuits. Questions 1, 2 and 3. Alright. Right, so I want you to describe the operation. So just to clarify, I'll do a description as an example. Okay, let me show you an example of how to describe the operation of one of these circuits. So I'm going to take that circuit there and I'm going to describe its operation. Right, yoink. Copy. Let me give you an example. Right. face in the way. So import from there you go. Right, so explain the operation of this circuit. Here's what I would expect you to write. I'd expect you to write. Okay, the circuit has a light sensor on input which detects low light level. So I'm describing the sensor first of all. As light level drops, the resistance of the light dependent resistor. It's important that you use the correct component names. The resistance of the light dependent resistor will increase. As it increases, the voltage across the light dependent resistor will increase. As this voltage increases beyond 0.7 volts, the transistor will saturate. When the transistor saturates, the light bulb will come on, emit light. So we get light out of the system. Oh. When it is dark. Okay, so that's the kind of thing I'm expecting to see. I'm using the correct terminology. I'm using saturate in there. I'm showing that I've got understanding of 0.7 volts. I'm remembering that and I'm applying it to this circuit. I'm remembering the names of the components. I'm remembering that that is a dark sensor. Alright, I haven't said dark sensor, but I have said it detects low light level and gives us a high voltage, and I've explained that. I've explained that we get a high voltage out of that sensor when the light level is low and how that makes this circuit operate. Okay, in the next couple of videos I'll have Yenka working, just so that I can demonstrate things. You can, as you saw on my computer, you can download Yenka for free use at home. You should do that, alright, so that you can copy some of this stuff. If you haven't done so already, go ahead and try and get it downloaded and use it now, and you can copy these circuits that I'm doing. Okay, right, okay, so you've got tasks to do, and I'll set an assignment for when you watch that video. Brilliant. Thank you very much. How do I stop this? I literally do not know how to stop this video.